Hello friends, welcome back to my channel. Our today's topic is complex numbers. Now what are complex numbers? Complex numbers are nothing but combination of a real number and an imaginary number. Today we are going to see what are real numbers and what are imaginary numbers and how we can solve a problem which includes both of them. X square plus 1 is equal to 0. This equation we can write as x square is equal to minus 1. A real number whose square is minus 1. Is this possible? Is there any such number, any such real number whose square is minus 1? No. This means this equation has no solution. To solve such kind of quadratic equation, an imaginary term denoted by I was introduced. This I is root of minus 1. It means I square is equal to minus 1. This term was introduced to solve such kind of quadratic equation in which we have a real number whose square is minus. Standard definition of imaginary number. A number of the form bi where b belongs to r, this b cannot be 0. B belongs to r means b is a real number. What are real numbers? Real number includes both rational and irrational numbers. This I is root minus 1. A term bi is called an imaginary number. This is an imaginary number in which b belongs to r, b cannot be 0. Value of I is root minus 1. These are some examples. Root minus 25 is 5i, 2i minus 13i. These are all examples of imaginary number. Now what are complex numbers? A number is of the form a plus bi. In this, a is a real number, b is also a real number, I is root minus 1. This we can also write as I square is equal to minus 1. A and B belongs to R. This is called a complex number. It is denoted by Z. Z is equal to A plus BI. This A is real number, B is real number, I is an imaginary number which is root minus 1. So these are the standard definition of imaginary number and complex number. In this table, we have given some numbers. See this Z is the notation of complex number. See, some complex numbers are given. We have to write these numbers in the form of a plus bi. Then we have to write its real term and imaginary term. 2 plus 4i. This is already in the form of a plus bi. So we will write this as it is. Real term, this 2 is the real term of it. Imaginary term, 4. 6i. This we have to write in the form of a plus bi. So 0 plus bi. Because a term is not given, it means it is 0. So this is 0. Real term. Imaginary term is 6. Sorry, this is 6. Now this 7 we have to write in the form of a plus bi. Imaginary term is not given, it means imaginary term is 0. So this is real term is only 7. Imaginary term is 0. 3 minus 5i. This is already in the form of a plus bi. Or you can write this as taking this minus side inside the bracket. So real term is 3. Imaginary term is minus 5. When real part is 0, we say that this is purely imaginary number. This 6i is purely imaginary number. When imaginary term is 0, we say that this is a pure real number. Equalities of two complex numbers. See, two complex numbers z1 and z2 are given. z1 is a plus bi and z2 is c plus di. We will say that z1 is equal to z2 only if a is equal to c and b is equal to d. See, in this example, x plus yi is equal to 4 plus 3i. This equal to sign means x is equal to 4 and y is equal to 3. Then we say that two complex numbers are equal, if their real parts are equal and their imaginary parts are also equal. Conjugate of a complex number. Suppose we have a complex number z is equal to a plus bi. So its conjugate is this imaginary term is with the plus sign. You write this with a negative sign and it is denoted by z bar. So this is the conjugate of a complex number. See, 3 plus 4i. This we will write as 3 minus 4i, making this term negative. This is positive. Now I am writing it with a negative sign. This will become minus 7i plus minus 2. Real term as it is, only imaginary term. This 3 will remain as it is. 5i will become minus 5i. This is the conjugate of a complex number.